So now we've seen conceptually how MapReduce works. In the next lesson, we'll talk about how to write the code to perform these MapReduce jobs on your cluster. But before that, let's go back to the cluster. Just as we saw with HDFS, there are a set of daemons, which is just a piece of code running all the time, running on each of these machines. There were the data nodes and the name node. When you run a MapReduce job, you submit the job to what's called the job tracker. That splits the work into mappers and reducers. Those mappers and reducers will run on the other cluster nodes. Running the actual map and reduce tasks is handled by a daemon called the task tracker. The task tracker software will run on each of these nodes. Note that since the task tracker runs on the same machine as the data nodes, the Hadoop framework will be able to have the map tasks work directly on the pieces of data that are stored on that machine. This will save a lot of network traffic. As we saw, each mapper processes a portion of the input data. That's known as the input split. And by default, Hadoop will use an HDFS block as the input split for each mapper. It will try to make sure that a mapper works on data on the same machine. If this green block, for example, needs processing, then the task tracker on this machine will likely be the one chosen to process that block. That won't always be possible because the task trackers on these 3 machines that have the green block could already be busy, in which case a different node will be chosen to process the green block and it will be streamed over the network. This actually happens rather rarely. So the mappers will read their input data, they'll produce intermediate data, which the Hadoop framework will pass to the reducers. Remember, that's the shuffle and sort. Then the reducers process that data and write their final output back to HDFS. So let's have Ian run a job on our cluster.